Hi everyone, this is Group 5 from Section 10, and I'm Ooi Jia Hoong, together with my teammates Lim Ting Wai and also Lim Yi Jian. Today we are here to present about our Milestone2 report, which is about CPLD familiarization. So, first of all, we are required to design a BCD counter, but in Quartus, we cannot directly build a BCD counter. We must use LPN, which is also a collection of pre-built digital circuit modules that can be customized to fit our design requirement. So we set the LPN with the parameters such as the output as 4 bits, with the maximum count value as 9, the reset value as 0, so that it can count from 0 to 9 and back to 0 again. And next, we are going to design a BCD decoder. So a BCD decoder is basically means a digital circuit that takes a binary coded decimal inputs and produces an output that activates one of the several output lines based on the value of the BCD inputs. So the decoder we decided to use is the 7442 BCD decoder, which has 4 BCD input lines and also 10 output lines, with each output corresponding to a specific decimal digit from 0 to 9. And lastly, we're going to connect both of them together, just like the figure here. So now that's all from me, and now I'm going to pass to my teammates Ting Wai to continue our presentation.
Hi, I'm Lim Ting Wai. So now I will show you 2.4 mapper. This is the mapper circuit that we designed in the Quartus. So now mapper is a type of logic circuit that performs the function of converting one set of logic function to another set of logic function. So this is the mapper that we designed in the Quartus. The VTO, this is our compilation result. It is successful and we create a symbol for the mapper. Then we move to the circuit stimulation the circuit. So we implemented this mapper symbol in this circuit. This is a partially completed circuit after we connected all of them. The BCD decoder is connected to the mapper according to the pin numbering. The output of the mapper is connected to 6 output ports. Lastly, we run the simulation. So I show you in the Quartus. The night rider, so this is our clock, prescale, and the LPM counter. Then we connected to the decoder and then connected to the mapper according to the numbering. Then we connected to the 6 output, that is our 6 LED. So after that, we compile it. This is our compilation report in Quartus. So after that, we run its waveform. So I will show you the waveform is here. So this is our desired output of the result. That's all from me. Thank you.
Now we're going to create a slow clock signal. This is the Verilog code that creates a slow clock signal from an input clock signal. It works by counting down from a certain value, and when the counter reaches 0, it toggles the output clock signal and reset the counter to its initial value. This slow clock signal can then be used for other purposes in this circuit. To use this code, we need to compile it and convert it into a simple file. To compile this prescaler.v file, first we need to set it as top level entity and compile. So this is the compilation report. To convert it into a simple file, we go to File, Create or Update, and select Create Simple File for current file. After creating, we can go to Night Rider file and input the prescaler block. Now we're going to assign pin number for each output and also input. To do so, go to Assignment, Pin Planner. In this window, we can assign whatever pin that we want to use. After assigning, close the window, set the Night Rider as the top entity, and compile it. Now we're going to save this circuit into our CPLD. To do so, go to Programmer, Hardware Setup, choose USB Blaster. Next, go to Add File, Output File, choose POI file. Now check all the boxes here and click Start. Now the progress shows 100% successful, means that the circuit is already implemented in the CPLD.
So this is the hardware setup. To connect CPLD with the breadboard, we use male to female jumper. The female part of the jumper is connected to the CPLD pins that we assigned just now, and the male part is connected to the breadboard. This is the connection of the LED. We use resistor connect with the anode led of the LED, and the cathode led of the LED is connected to the ground. Now, this purple wire is connected to the ground. So if I plug in the purple, we can see the LED light ups.